1, 2, 3, 1, 2, 3. How do I check? Okay. It's working. Yeah. So I'm recording this lecture, and I wanna speak about these data analysis and eye tracking driven experiments, and you can access this lecture later. I'm currently in the lecture room, so I'm showing to Manon like how to use this SMI big gaze equipment. And so I'm also going to show here some ideas about what kind of analysis techniques you can use in your eye tracking experiment, and also how to use ChatGPT. So typical metrics in eye tracking include areas of interest on the screen. I'll show you later. Dwelling time, so how long do you look at the spot? Well, fixations, points where the participants look, their count, duration, scan path, series of eye movements, and heat maps. So you can perform descriptive statistics or inferential statistics. For example, t-testing is a common technique. But remember that it's actually a small sample experiment, and probably you also should use descriptive statistics because it's small sample. So if you have 7 participants, it's not enough for statistical significance. And obviously you would need to test for normality, distribution, and all the other things that are necessary for t-testing. So this is an example from my previous research. Here's the reference, and this is how can it look in your thesis. So you have on the left side, you have correct area. So task 1, 2, 3, etc. And you can imagine this as your model. So for example, you have this model A, which could be, for example, static conditions. So static model, and then task 2 is animated model. So you can have this comparison between 2 conditions.
But each task is a model.
Yes, for example, you can do this. And the alternative, you can select, for example, different students. For example, you have 10 students, 5 is in one condition and 5 is in other. And the tasks, then they should be the same for all. So then you test, you need to decide essentially, do you test between 2 conditions or between 2 participants. So you have these experienced modelers, you have these novice modelers, this one approach. Another approach could be you have one model and then another model, different model types. And frankly, I would suggest that you use models because you don't have a lot of participants. So it's not easy to distinguish the 2. So you should focus on how you can create, essentially, how you can create 2 different model types and what are the differences that you're going to test. Then you can see, compare the 2 conditions. So in this case, it's like the correct area, so where the question is located. And in this case, I find that one is experienced. Well, in this case, I was actually testing between the 2 participants. In this case, the participants who were experienced users of the course area, they found the target area faster, quicker, with less time than compared to the people who are not experienced with the content, which is obvious finding. And then you find these descriptive statistics, and then you explain how it works. And obviously the score of correct score is also better. So you can use the same logic to your thesis in a way that you can design the correct area, and then you can compare, for example, is it found better or quicker? Is it having more dwelling time? Is it first sequence or last sequence in one condition and in another condition?
Yeah.
Yes.
Sorry to interrupt.
Yes,
but,
yes.
The correct area, can it be seen as the area of interest? I think so, huh? It's the main area of interest. That's what
yes,
mean,
you can
correct.
define it. You
Yeah.
can define this area, and I will show you later. So
Yeah.
you have this area of interest.
Yeah.
You have this model,
Uh-huh.
and then on this model you can select this a square box, for example, or you can draw, like some shape, and you can call it this area of interest correct answer.
Yeah, there lies the answer to
Yes, yes, and then you can perform statistics on this. So, for example, you have this model A, model B. In both, you have correct answers, but some condition changes between them. And then you can see through the statistics. So, sequence. So, sequence is like the number. Like, okay, you have multiple areas of interest, like 6, 10, whatever. And so, sequence represents like what is the order. Like the participant starts looking at the model, so the first area of interest, second area of interest, third area of interest, and this can be used to analyze how quickly the participant finds this area of interest. For example, this is one of the multiple statistics. It's more also the creative process, by the way. It's not like you need to read this data and then you need to interpret this. So it's not going to give you the answer. So sequence can mean that it's easier to find, for example, but other data needs to be interpreted. So it's creative process in a way.
And dwell time is a time that it fixates on certain point?
Yes, it's the total time. So you have this area of interest, you look at this area of interest, and then the total time you spend looking at this area. So, and this can also signify like the area, like more important areas of interest or less important.
And maybe the participant is looking at the wrong place.
Yes, yes.
That's the idea.
Yeah, yeah. I'm going to show you later like the visual analysis. So how you can like, because this is just the statistics. So these are the numbers, but then you have the more important part, which is visual analysis of the paths. So and that's what I see here. So the primary goal is qualitatively and visually explain the attentional shifts and behavior of the participants. Actually, these statistics come from the visual analysis. So how you define the areas of interest, and then they inform you with the numbers, not the vice versa. So that's the first step. So you have different types of analysis. I'm going to go through them. One is heat maps. And for heat maps, you can select for average dwelling time, which is the total time you look at the thing, but averaged across all of the people. Number of sequence, total and average number of fixations, because you can do for individual participant, you can do for all of the participants. It's different levels of analysis. It's also important to control. Scan paths, it can be individual or aggregate. And then you can obviously select the menu, the areas of interest. But I'm going to show you like how this looks. So for example, you have this model to analyze. So for example, it's one of the tasks. And in this case, you have static version. And we were also checking, for example, with animated version, which is like you have this token flowing through this. So it's kind of visualizing the logic of the model. So here it splits, boom, 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 and then it goes. Here it gets stuck. Here it gets stuck in this place. And then here you need to calculate how many times the participant looks at M. And these are the questions. Okay, so you have this model, you have this experiment, the participant answers this question, and then you have this heat map for all participants. So that's for 7 participants. You have this nice visualization. So it's exploratory. It's first step. You open, for example, heat map. So you look, what is the most important part? Maybe, for example, you want to focus on a specific participant. So then you can do that. You open for one participant, and then you can see. Sorry, I'm going to show you, but. In a way, you have differences, like one participant and all participants. Yeah. So you need to have at the same time. It's a creative process. So you have this data, and then you can go this direction. You analyze, you look, you make note. Then you go back. For example, you look at another direction, and then you kind of like creatively analyze all these things, and then you have some picture. But like they're all the tools, but you need to look at the tools, and then you need to analyze them. So alternative can be a scan path. So for example, this is the option where you need to focus on specific aspect, because in here it's very hard to distinguish. Okay, you have this huge here and here and here. Okay, maybe a lot of here, a lot of here, maybe and fewer here and here. Okay, but that's not good enough. So maybe you want to focus on one specific participant. And then it's, if you consider, for example, one participant is a representative of all the participants, it's easier to analyze already. So you have this, let's say, something here, here, and but by the way, you can also animate this. So it's animated. I'm not showing this in the slides, but it's actually a video. So you can actually play how the participant looks at different areas. So it's like appearing like boom, 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 boom. And so you actually see this visually, and it's a dynamic aspect. And by the way, in thesis, it's also a little bit hard because you need to describe dynamic picture, but in words. So it's also like one of the things to consider. And then, for example, you can select for the granularity, you can even select like the specific snippet of all the data. So for example, in here, you have this first 10 seconds of the first participant in the last model. And then you can immediately see, okay, so he's not starting from here. So in here, you can see, okay, like there's something going there. But in order to know the dynamic, the order, you like make it even more granular. You look at this picture and you see, for example, he starts immediately from the first question, because this one is related to this area. And so like the first 10 seconds, he's looking at these two aspects. So what I'm showing to you is like you went from this picture to actual finding that you can focus on this specific area, and then you can draw some conclusions already from this. For example, the first thing that the participants do is like they look at the first path, first question, and that's already some conclusion already. Like,
he doesn't look at the whole model, trying to understand the model. Just
I mean, like in the first 10 seconds, obviously, but he's trying to do the whole model, because here you can see that he's actually trying to read the whole model. But like in the first 10 seconds, it's the first question, like the first part, or like actually the first question, then the part where it's related.
And it's like there is a red dot and a yellow dot. What does that mean?
Yeah, I think yellow dot, it's the latest eye gazing path, I think. So but like essentially, like the red dot is like the actual eye gaze. By the way, in the eye gaze, you can also focus on right eye or left eye, and you also should focus, because different data.
Is it?
It's not so dramatically, but you should use the same eye. And usually it's by default it's the right eye. So, but you shouldn't go like left eye, right eye, because it can shift. You should use the same, let's say, thing. Yeah, by the way, for the accuracy of the eye, you can see, I'm not showing in this presentation, but like in there, you have validation, where essentially you have to look at 4 dots. And so then you can see, okay, like for how far away is actually the actual eye gaze from the dot the participant should be looking. Because, for example, it's validation. So, for example, I say that the participant has to look at here, and then you see the eye gaze is visualized in this area. So it says that the data is more or less accurate. You know, it's not here. You always have to validate and calibrate and validate with the participant the eye gaze. And then you can see, for example, right eye is like within like 1 to 3 millimeters away from this dot. Okay, so you use the right eye. And then another point, you can combine the analysis. So in this, I want to show you that heat map shows the areas of interest, but it's not showing you the order. And the left one, it's also kind of showing you the areas of interest, but it's harder to read it. And then it's, you know, like you're not able to see the order in the sequence of the eye gazes on the right hand side. So that's why you need to combine the two. Not this specifically, but the overall principle is that you need to combine different perspectives of analysis. And then you also need to combine the different level, like do you have individual participants, or do you have all of the participants, so the aggregate measure? And there's also a difference. So for example, in here, on the left-hand side, this participant was more widespread. So he's like focusing on the first question, the first route, and then the second question, then the second route, the third question, this one. Apparently, for him, it was much more easier for this to comprehend the last question for some reason. Because I mean, like, you also have this internal semantic meaning in a way, because you also need to combine with your own interpretation. So it's showing you one perspective, but in this case, you can clearly see that the last question, it's can F and R be executed at the same instance? And it's actually easy question. So that's why he's not spending so much time, this particular participant. Maybe it's one of the hypotheses. You can also confirm it or propose it, but like you have this interpretation, potential one. And then you can compare this with the all of the participants. So actually for other participants, this question was actually harder, even more harder, for example, than the second question. And dwelling time and the number of fixations, it's usually corresponding to it's either very important area, or it's difficult area, or if it's not looked at, it's the area that is not noticed. So those are the implications of the high area of interest, low in area of interest. So it's either important or difficult, and you need to distinguish what are the two, because those are not the same things. Or they can be both difficult and important. So
or ignored then?
Yeah, or ignored in case if it's not looked at. So the third one is only capable if it's not looked at. Then this one is the analysis I kind of like suggest you to use, because I think it's for the model specifically, it's kind of nice and interesting, because first of all, it's areas of interest. So you have this grid. In this case, it's 16 by 16. So, and then it automatically does the calculations for you. And then you see in a visual format, okay, like in this sector, the participant was looking, for example, an average participant, they were looking for 667 milliseconds, which is, I don't know how, like, on the, all like, I need to see the calculations, how much is in milliseconds, because it's not like the seconds, it's, I don't know, like 10, 15 seconds or something. I don't know, need to check the numbers, but it's actually different for individual. So then again, like the same principle, you increase the thing, and then if you average this, so all the tries, all the participants, so for example, if the participant was not looking in this area, it's already, you know, like 0. So 0 plus 0 plus 0 plus 0 plus 10,000 is equal like 600. So you need to be also a little bit smarter on this, and change between the different levels of analysis. And in this one, you can also use other data. So in here, it's the number of fixations. So, and the important question, the important thing I want to point out is that fixations and dwelling time, they are correlated, but they are not the same. So they can give you also different pictures. So for example, in this area, apparently it was more looked at. It can be either more important or more difficult to comprehend. Yeah.
What is then, how would you define the difference between the two?
Well, fixations is the number of times the person was looking at the area. So you have this, you look at the area, it's counted like +1. Then you look away, second time, +2. So in this area, it looks like 2. And then you shift between the areas, and then it's like +1, +1, +1, +1, +1. You know, so it's like tracking your route. But in the end, you have this the number of times the person was looking at this area repeatedly.
Yeah, and not the time.
Yes, okay. Yes. And so in here, for example, this area was looking more often at this time. Then this one also, but like slightly less, you know, like, so you have these different, slightly differences in the statistics, and you should be careful about them because they are minor details. Yes, I mean, like they can be generalized. Yes, but sometimes, you know, like there's the devil is in the details, you know, so you should be careful about, like, you know, like the detail and how do you interpret this. It's not that you have to be ultra careful not to do all, like, no, but like you should be careful about them. That's the most important thing. Then you have areas of interest. That's what I was explaining, that you have correct area of interest, and then you can define it. Okay, so this is the question one area, and then you have this area which corresponds to the question one. So, and then the pattern can be, for example, if the person is looking at this area first, then at this, then you have some correlation. But the person can look at this area, then this area, then this area, then this area, and then this. And this could be visualized in two different patterns, let's say. So the first pattern is like the person is looking at all the questions and then solving the questions, or he's doing them one by one. And this is a totally different picture. So it's not the same, like, you know, like you have this acknowledging first and then solving, or you have first question, first, you know, like pattern, yeah, answer. This is what I meant about like the areas of interest inform your descriptive statistics. All the data is visualized here. And then that's what I meant, like another perspective. You can visualize these patterns as a sort of, okay, so you have these areas of interest, but then you want to visualize, okay, what is the actual order between the two? And then here you see that participant 1, 2, and 3 a bit. So they were having this pattern. They were looking at the first question area, and then they were looking at top root. So they were looking at first question, first root. And then within the first root, they found this area which is specifically related to answering the question. So that's visualized here. Obviously, it's also like a lot of the data, you need to distinguish this. And by the way, in exploratory analysis, you don't have to make the full classification of all the analysis, I think. No, because it's too much, sorry. And also, like in our publications, we are going to argue, for example, that because we are using this data for our publication, we are going to argue that it's exploratory in nature, and it's very hard to distinguish because it's a lot of data. You need to dig in the data. But you can do some exploratory findings. You can prove them. You can show these patterns, and then essentially what you found, you report. The more you found, the more you report, the better. So, I mean, like, and here's a balance, you know, like at a certain point, you need also to write your thesis, to send it, etc. So it's a balance. So, you know, like if you write too little, if you find just one pattern, it's not enough. If you find, you know, like so many data, okay, it's very good, it's very rich thesis, but it's also gonna take a lot of your time. So you need to balance between the two.
Put research question and objectives.
Yeah,
Idea.
So you need to have these research questions and then target your findings at this particular research question. And the same picture, but for all participants, but like it's aggregate values. So, and we see that this pattern, looking at question area first, then the question area, and then the top root, it's correlated. So in the first seconds, the participant looks more at the question and then starts more looking at the area of
interest.
Yes, at the answer. Yeah. And then obviously you can also do the same for individual patterns. So question, then area of interest relevant to the answer. Yeah, and by the way, here's another pattern. So like this is a start. It's not, maybe it's not so visible.
Maybe because picture, so what you see is the time on the x-axis.
Yes, time.
And on the y-axis is what? Each row is one.
Yes, it's a try. So, but like it's a technical sort of error or something. But it's for the static condition. In principle,
Yes.
all the participants should have been only running one try. One try.
Try.
Yes. So for static image, somehow it shows you have like one participant, but he's doing like 6 tries. I don't know like why. It's a technical thing, but like in this particular case, you focus on this one. But like all these things, they should represent the number of tries. So the participant, he has this condition, this model, he starts the model, and then you have the time being recorded.
Mm-hmm.
So it should be more prevalent in the animated condition, but for this one, I'm not exactly sure how this happened, actually.
But this is for all participants.
No, it's one participant.
This is one participant.
But each participant is coded like I tracking 0, 1, the first participant, the first letter. And then this picture should be actually more present in the animated conditions. But for example, yeah, because friendly, I don't know like why this multiple participants happened here. In principle, this should be like here, like the first participant, first try, second participant, second try, first try, third participant, first try. All these things, they somehow overlaid because SMIBGACE is also not very novel software. It's also lagging a bit. So these things, they can somehow happen. So you should also be like sometimes checking, okay, like is the software actually working? Why is this happening? So this is one of the examples, like so. Apparently there should be only one participant, but somehow this happens. And there's also no good idea like to answer because it's not supported anymore. So you don't even like know it. It's harder to find information. So you just kind of like try to find the answer and just like exclude the data because it's obviously some lack. Yeah. Okay. So overall thoughts. It's exploratory process. It's most creative part because you don't have the right solution. You need to find the right solution and use all these different tools. It's iterative process. So you get this picture, then that picture, then you go rest, then you do some note writing, then you again analyze, reconfirm your hypothesis, then you go rest, etc. So the most important lesson maybe is that you perceive this as a sort of continuous process. So maybe you don't have to spend like all your 8 hours a day of work or whatever on this analysis, but make sure that it's continuous. So you're not doing this in one go, because essentially this all boils down to looking at the data, and then the patterns start to emerge. It's kind of like in cognitive science as a black box, like thinking. So the ChatGPT is based on the same principle. Nobody knows how it works, but it works. So you essentially should go to this data, look at it, rest, look at it, rest, write, analyze, go do something else, do some other analysis, rest for a continuous period of time, several days. So if you need to borrow this equipment, consider 1 week, 2 weeks, because you also need to analyze the data, write the data, and some other people have to use it. So look at the data.
Maybe I'd like to add very briefly that if you have a certain condition, like static model versus animated model, it's one example, there are others, then it's always helpful to just look at differences and trying to make sense of them.
Yes.
Like, okay, we have seen a whole box of tools, then you can start comparing, like what did they do in the animated condition, static condition, what is the difference, how can I make sense of it?
Yes.
It's
the differences. So
that helps to make sense of all the data.
No, I mean like the science and scientific thinking is based on finding the differences and then making sense of everything. So to compare the data, so to follow this understanding, for example, you can have this table, and then you have this task 1, and then you try to explain what do you see about task 1, like in this model type, in this data analysis perspective, at this level for aggregate, for example, the people are doing this and that as evidenced by this and that participant. And you do this, systematically for the first model, the second model, the third model, the fourth model. Obviously, you take rests in between, and then you have this at the end. You have this summary table, and I think this is like the, let's say, that's how you measure if you have done enough. You know, so you have this table, you try to fill this table, you try to make it accurate, valid, right, etc. You focus on this table, and at a certain moment you feel this saturation with the data analysis, and that's when you stop this checking. I think that's more like, you know, like feasible approach, how you decide, like, is it enough, is it not enough. And so, like, one of the error I would like to point out is it's actually from the master's thesis students. So we actually redraw the thesis because we don't find it's good, very good, many errors, but one in particular in here, that's on the left side, it's his analysis. So that's what he drew. So, like, that's the scan paths plus the areas of interest and how the people are looking at it. And he didn't draw the connections to the answer area. And so, like, it's likely based because in here it's not mentioned, you know, so it's relatively not so many answers in here. So a lot of here, but like not so much here. Very small circle for this one, for example. But for example, already here, like, he should have drawn, like, you know, some circles here as well, following the same logic. Maybe it's too small for him, but like in another view, it's actually often looked at, and that's important. So we are actually drawing like a paper based on this, and that's important for this analysis because you use animations to answer, and then this picture is not shown. So, you know, like, that's what I'm saying about like the details. You need to look at the data for a long time, and if this error is found, like, you know, like when you analyze and prepare the data and you show this data, it can be actually a reason for reworking this. It's not to scare you, but like just to focus, you know, like, so you're not doing these mistakes. Okay, like you have this abstraction on the left, which is the finding you present, and then you kind of like in between you have this model or that model. So I would say you just focus on this analysis instead, and then you are not trying to do something like this because you can miss some details. You try to be more data-based. That's much more safer route than doing this. Yeah, and one extra thing, it's actually for your thesis. In methodology section, present something like this. Obviously adapt this, but it's for methodology. So the eye tracker, the hertz of the monitor, the screen size, the distance between the monitors. So just copy paste it, edit it, but that's the, how do you say, convention in eye tracking studies. You just present this. And then for qualitative analysis, which I kind of suggest to you that you do, so that, for instance, you don't see so many findings in eye tracking results, but then you need to give something extra, you know, so it's consistent and rich, you know, so you don't find so many findings in the eye tracking. What you can do qualitative analysis. You can do semi-structured interviews. So you present some questions, for example, how did you find this model? Was it clear to understand? What did you like the most about like this visualization? What didn't you like? What would you like to improve, etc. And then you can use this data and combine it. And there's some suggestions. So, you know, like, it's based on interviewing skills. So use prompts like aha, what else, etc. You don't ask double barrel questions. Like, what is your favorite color and why do you like it? It's double barrel. Don't ask loaded questions like why do you like the red color without knowing the person likes the red color. Give space for the participant to speak, etc., etc. So, and then you can, yeah, it's a different thing. But yeah, I was also like to point out that if you know like how the facial emotional recognition works, or EEG, electroencephalography, or if you wanted to know this, you can also use semi-structured interviewing, and then because you can track the emotions of participants by recording the video of the faces, and then there's some simple algorithms, and then you can, if you develop something like this, we can also use this in our publications because it's something that is not explored, emotions. So because emotional aspects of comprehension, it's related. So many participants, they say, for example, in our study, so emotions were important for them. They were feeling confusion, stress, interest, curiosity, motivation. So emotions is important aspect of this. And the video recording and the emotions, they can be checked on the face. Obviously, you need to have like ethical considerations. You need to ask for this, how you say, ability to record the faces for emotional recognition. You need to, by the way, ethical recognitions, you also have this. I mean, like, it's more or less standard format. You anonymize the data, you treat with ethical considerations. Not many people will see the data, like the supervisors, anonymized, etc. But the thing, I sent you this a couple of links, but also for conceptual modeling.
But we need extra software for this, right? Equipment, I mean.
Yeah, I mean, like I sent you the link. Not
Introducing-
equipment, not for equipment, no.
Mhm.
Essentially, it's only based on you record the face on any camera, laptop camera, and then you have this video, and then you insert this video into this software, which is usually relatively easy to program. If you know how to program, you take this program, you install it, and then you have this data. So it's
okay. But
input
for
data.
the thesis, let's not put too much. I mean, you're now doing eye tracking, and you should stick to that. Okay, this is another topic.
Yeah, I'm just saying, like, if you some of you know, you can try doing this. Yeah. Okay, and so for ChatGPT, for academic research, so likely you have experienced this in some way or another in your academic work already. So asking questions, asking to analyze the data, etc. So for this thesis, you can use this data, ChatGPT, but it needs your input as well. So you couldn't ask, like, do the thesis for me. It's not going to work. If you have some specific questions which you know how to answer, you can ask the questions, and probably you should even ask the questions of ChatGPT. Here's a reference which I provide to you. You can read this for sources, for references. You can use this. But please read the literature before using it, so know how to use it. Don't just use it because you think it's how it should be used, because you need to validate the approach, etc. Difficult. Use ChatGPT 4. It's more accurate, much more powerful. $20 a month is reasonable, and then you can use 50 prompts every 3 hours. You can use ChatGPT, for example, for if you have this qualitative data. Okay, it's here. So you have this qualitative data, and then you can ask the ChatGPT. Long story short, you have these interviews, you transcribe it, then you ask prompt. In this and that experiment, please give me a structure of the themes that the ChatGPT give. That the participants talk about, and then it gives you a list of themes. You try to validate it. Please read it carefully, not just like, okay, like he gave you this answer, you copy paste it and that's it. Sometimes there are errors, and like again, like with the previous thesis, it can be small but important details that you miss. So yeah, for eye checking it's not working, so not very good. I tried testing it, but like, some results, it needs to be more careful. So prefer manual work, but you can experiment with this. But again, like, try to prove it. Yeah, and essentially the overall conclusion is that treat it like a tool, a research tool. So if you can reference it, it's not plagiarism in references. So if you're not referencing it, this is a plagiarism. So it's a big issue then. If you mention this as a reference, so okay, you're honest. You're saying, okay, like, I use this ChatGPT. Actually, it's suggested in the literature to be used because it's accurate, powerful. Here are my reasons. Please read it. You can protect this decision. It's actually in some conditions it's powerful. But also use your internal judgment, because actually it's possible to see ChatGPT's responses and are they correct or not. So experts if they're really experts, they can really sense the like that it's lacking soul, if you want, so it's actually clear that the text, philosophical text, which is well written, the essay that is well written, and the one that is just ChatGPT, because it's always positive, always saying like, can you answer this, and he always says certainly, like always, so it's not, he's not going to say maybe, yes, no, like it's always trying to give you the answer. And that's only one perspective. You can use this in your thesis, but be knowledgeable about this. Yep, and that's it on the presentation. And then I also wanted to show how to work with SMI gaze. So for those who attended, not sure if I can record this, but if you, yeah, so
maybe it's good to maybe we can stop the recording, or just
yeah, I don't know, like if I can, if I should even record the eye tracker.
But if you do maybe a second video, then
yeah.
Otherwise,
okay, yeah. So that's all for this presentation. So how do I?
And more.
So that I don't.
No, it's okay.
Maybe leave and then you answer.
Yeah, no, it's the more the
the three bullets to left.
Okay.
Mm,
Stop
recording.
recording.